Okay, so we've learned about proportional ratios and equivalent fractions. I want everyone to think about what we already know about ratios. Everyone is thinking, what do we know about ratios? And then I'm going to call on one scholar. Okay, I'm going to go to Abriana. Go ahead, Abriana.
Okay, so I remember from ratios that that there are three forms that you could do them. One is ratios, two is fractions, and three is oh wait, no. There's three different forms. One is fractions, two is decimals, and three is percentages.
Thank you. So yep, ratios can absolutely be represented as fractions. Ratios represent a special relationship, and we can represent that special relationship between amounts by using fractions. We can use our two dots for our ratio symbol, and we're going to take a look at those in a minute. Let's think now to graphing points on the coordinate grid. What do we know about graphing on a coordinate grid using an equation? Everyone's thinking. What do we know about graphing points on a coordinate grid using an equation? That's x and y, remember, right? Like y is equal to 5x, or y is equal to x minus 3. I'm looking for a hand here. Now, so we've all had a chance to think. What do we remember about plotting on the coordinate grid? Let's go to, so thank you, Naya raised her hand. Go ahead, Naya.
I remember that so when we plot the coordinate on the coordinate plane, you would make a ratio out of it.
Say more about that.
So in the first quadrant, like we would plot it, the coordinates somewhere, and then our ratio would be 2, 3.
Okay, so yeah, I mean, if you have the equation, let's say y is equal to 3x, for every one y you have, for every one y you go up, you go over 3 times. So there is that relationship between them. And we're going to take a look at that later in this lesson also. So looking at the PowerPoint, a ratio shows the relationship between two values. They can be written in 3 different ways, which Abriana mentioned some of those ways. We have fractions, we have the colon, which represents a ratio in the middle here, 1 to 2, and we can also use the word 1 to 2. A proportion uses common multipliers and divisors to show the two ratios are equal. So I want everyone to look at these two fractions, and I want you to determine if they are actually equivalent. Show me on your hands, are these fractions equivalent? Is 1/2 equal to 3/6? Yeah, they are. 1/2 is equal to 3/6. And the nice thing about using proportions is that even if we didn't know this top number 3, like maybe that was a variable, maybe we could say 1/2 is equal to x over 6. We could use what we know about proportions to solve for x. We know that x would have to be 3 because that's the only way it could be equal, make the right-hand fraction equal to 1/2. There are 3 ways that we could find proportional, there are 3 ways we can find proportional ratios here. So the first method is by creating tables. Who remembers creating these ratio tables back in, I think maybe two units ago. Yeah, so we can also find proportional ratios. We can also show them by graphing. And we can also show proportional ratios using proportional reasoning. Each of these methods will bring you to a correct answer if you use them correctly. So I'm going to model using each of these methods, and I want you to focus on the steps that I use applying each of them. Okay, so the first method, using a table. We've got this situation here where Chloe can walk 2 miles in 30 minutes. If she keeps walking at the same rate, how long will it take her to walk 4 miles? So this problem's asking me to find the length that it will, the length of time it will take Chloe to walk 4 miles. I know it takes her 30 miles to walk 2 minutes. So I can create this proportional, this ratio table. So 2 miles for every 30 minutes. That's a ratio right there, which is written as a fraction. And I want to know, what is that if she only goes 1 mile? How long would it take? So I need to think to myself, what do I have to do to get from 2 to 1? To go from 2 to 1, we divide by 2. So if we do that on the top, to go from this side to this side, we need to do that on the bottom to go from this side to this side. My PowerPoint, there we go. Okay, so dividing 30 by 2 gives us 15. So we know now that she can go 1 mile in 15 minutes. To create my ratio table, I'm going to start by putting 1 for miles and 15 for minutes, because that is the special relationship that they have. If you have 1 mile, you have 15 minutes. For every 1 mile I go, it takes me another 15 minutes. So if I go 2 miles total, it's going to take an additional 15 minutes. So I'm going to add into my table, the next step is going to be 2 miles takes 30 minutes. If we continue the same way every mile, adding 15 minutes, we create a table, and we could do this up to any number we want. We could go up to 10, we can go up to 20. But you might learn that using a ratio table to go to do so many numbers may not be that practical or useful. You may not want to do 50 numbers in a ratio table, but you could skip. I could give an example here. You could do this by tens. You could have 1 and 15 for miles and minutes. And then you could say, okay, well, what if I go for 10 miles? Well, then the amount of time has to be 10 times as much. So that's going to be 150. What if I go 10 times more than that? 100. Well, 100 is 10 times more than 10. So, oh, don't do that. 100 is 10 times more than 10. So the minutes needs to be 10 times more. So each of these is times 10. So there are different ways of creating ratio tables. The most basic way is to go up by like 1 each time, or whatever your basic ratio is. So in this case, the basic ratio was 1/15. So we increase by 1 and by 15 on each one. So how many, I want everyone to think to themselves right now, how many minutes would it take her to walk 4 miles? All right, I'm going to list, Adelaide, how many minutes would it take her to walk 4 miles?
It would take her 60 minutes.
It would take her 60 minutes. And that's how you would use your ratio table. You would find the miles and then connect it to the minutes that match it. Graphing. So if we want to, before I go to that, how can we do this? So I gave you an example of maybe creating a ratio table in a different way. What if we're being asked how far she can go in 40 minutes? Or 40 miles rather, 40 miles. What can we do to change this ratio table to find, right? I got 2 hands up, let's get some more hands. What can we do to find how long it takes her to go 40 miles? Let's see, how do I do? Okay. Elos, I'm coming to you.
Basically we'll be able to find 40 miles because we know that for every 1 mile it takes 15 minutes. So we could do a proportional ratio comparing 1/15 and 40 over something, which we could find. So we could do like basic math in order to find how much minutes will be 40.
Yeah, absolutely. That's one way to do it. And another way that we could also do it, anyone know how we could do it? Can we just like add an extra box here to our ratio table? Let's see. The hands. Go ahead, Eric.
Or you could just do 4 times 10 and then do the same thing to the minutes. And then you would get 600 minutes.
Yep. So we could create another box in our ratio table. If we multiply 4 times 10, we get the 40 miles that we're looking for, and we have to do the same thing on the bottom, 600 minutes. So now using the graphing method, we know that Chloe can walk 2 miles in 30 minutes. We have our ratio table already set up here. If we want to graph this, what I need to do is I need to find where on my graph miles are and where on my graph the minutes are. So I see that my miles are on the y-axis and my minutes are on the x-axis. So for 15 minutes, it's 1 mile. So I would go ahead along the bottom. 15 minutes would be there, 1 mile would be there, and the dots do match. 30 minutes, which is right here. 30 minutes is on my x-axis, so I'd go along the bottom of my x-axis, find 30, and then I would travel up the axis until we get to 2. If we do that for, we could do that for 4 and 60. So 60 minutes is right here. Travel up until we get to a height of 4 miles on the y-axis and place another point there. And so we started to create a line. Just give me one second. All right. So using this line, we can answer the question of how far it would take her to go if she walked 4 miles. I could even say, what if she walked 90 miles? So by creating this straight line here, which my drawing is not straight, but the black line is, we create a line and we can then go and say, what about 90 miles? 90 miles. Everyone take a look at the line that we created. Not 90 miles, 90 minutes. If she went 90 minutes, how many miles can she go? Take a look at the graph. She went 90 minutes walking. Naya has a hand up. Who else has a hand up? Who else has taken a look at this graph and has seen how many miles she can go in 90 minutes? Okay, let's go to Katie.
For 90 miles, they'll go 90 minutes, they'll go 6 miles.
90 minutes, she'll go 6 miles. And can you explain how you did that? Explain your process.
I got 6 miles because I went down to the x-axis. Yeah, I went down to the x-axis and I found 90, and then I went up to the y-axis and found where they met, and they got 6.
Okay. So you traced it across and you found that it was 6 miles. 90 minutes is 6 miles. Thank you. So the important thing for us to realize is that this line that starts at 0 and then goes up in a straight line, that represents our ratio. Because for every, let's say for every 15 that we move across to the right on the x-axis, it goes up by 1 minute on the y-axis. For every 15 we move over, we go up 1. 15 over, up 1. It's always that same special relationship, and that makes it a ratio and it makes it a proportion. Okay. So everyone should be turning to, we're up to the we do. So in your packets, make sure that you're on the page of we do 1. At the class field trip, there must be 2 adults for every 3 scholars. If there are 27 scholars going on the trip, how many adults will need to chaperone the trip? Use the table below to solve. What is this problem asking us to do, Elijah? What is the we do problem asking us to do?
Is asking us how many adults need to watch this and have to watch the scholars.
Yes. How many adults are needed for the number of scholars going on the trip? And what information do we know, Lemuel?
The information that we know is that for every 2 adults, there must be 3 scholars.
So how many adults for trip? We know that, thank you, Lemuel. We know that for 3 scholars, there must be 20. I mean, for every 3 scholars, there must be 2 adults. 2 adults. So what should we do? What should we do first? Joseph, what should we do first with our table here?
I think what we should do first is that first put in the scholars, since we know how many scholars are in the trip.
Okay, so what number is that for scholars?
27.
Okay, where would you put that in your table?
Well, first I would skip count by 3, so I'll go 3 in one box, 6 in another.
Okay, so your first step is not to just write the number 27. So we're gonna, you have a process here where you're gonna go like 3, 6, 9, 12.
Mm-hmm.
Okay, so let's start with that then. Let's start with the first number you said was 3 scholars, right?
Uh-huh.
How many adults do you need if there are 3 scholars?
1 adult.
Take a look at the problem.
I mean, 2 adults.
2 adults. So the first step would be to, thank you, Joseph. The first step would be to fill in 3 scholars and 2 adults. Now, Joseph had the excellent point that we could use, we're basically using skip counting. So to skip count up from 3 all the way up to 27, because our goal is to find how many adults for trip for 27 scholars. That's what we want to get to. Skip counting all the way up. Let's see, I'm gonna go to someone, I'm gonna pick one of these things, one of the entries in this table here. Let's go to, let's go to Katie. Okay, so Katie, so we skip counted from 3 all the way up to 27. How do the numbers of adults relate to that? What's the special relationship between adults and scholars? There's a pattern that goes on here.
The relationship, okay, yeah. So the relationship between the adults and the scholars is that every 2 scholars, every 2 adults, there's 3 scholars. And so then, like for adults, if there's 2 more adults, then that means there's going to be 3 more scholars. So then it's going to be like adding on.
Thank you. So we're also skip counting by adults as well. So we're adding, go back, we're adding 3 for each of these, plus 3, and we're adding plus 2, plus 2, plus 2. This ratio of 3 and 2 is the same for every one of these steps. So what is our answer? Oh, this one is not correct here. This should not be 24, this should be 27. So go back to our actual we do problem. We're being asked to find the number of adults that we need. Have we solved our problem yet? We need to report an answer. So let's go to someone I haven't heard from, Esther. Esther, Esther, what is our answer?
My answer is 18.
18 what?
18
Yeah, we need 18 adults. Okay, everyone go ahead, look at the second we do and start reading that silently to yourself. Okay. We're being asked to plot the points in a table and use a graph to find an equivalent ratio. Ms. Hamilton must purchase ink for the classroom. She bought 2 milliliters of ink for $3. Part A asks us how much will it cost to purchase 6 milliliters of ink. There's a ratio table here on the front. Anaya, what's the problem asking us to do? What do we know?
The problem is asking us to find how much it would cost for 6 millimeters. And we only know that for 2 millimeters, it's going to be $3. So we're going to have to use that ratio to find out how much it would cost for 6 millimeters.
Okay, these are, Anaya, these are milliliters, because we're actually talking about volume here. Like, you know, if you drink a bottle of water and it says 1/2 of a liter, a big bottle of water. So yeah, milliliters of ink. We have this ratio table that's set up here. I want everyone to think about how you can go ahead. Actually, what I want you to do is go ahead and start filling out this table. So I want everyone to fill out the ratio table for 1, 3, 4, 5, and 6 milliliters of ink. All right, I'm gonna go to, let's see. Nana, you have a hand up. Do you have a question? That's fine, Nana. Go ahead, Nana.
Oh, it was a question.
Yeah.
So since I don't have the packet, should I write just the whole thing down?
Yeah, you can do, you can do your best to, as quickly as you can. You don't have to draw a perfect table that has all those boxes, right? You could do something so simple like this. You could have I for ink, P for price, a line down the middle, $2, $4, $3, right? $6. So you don't take up too much time writing tables and things like that. So I already revealed the first step here. We know that, okay, so 2 milliliters is $3. 4 milliliters is going to be $6. Josue, go ahead and fill out 6 and 8 for us.
6 will be $9.
6 would be $9. Okay, and what about 8?
And 8 will be $12.
8 would be $12. Okay, so let's go ahead and let's look at our Quincy, can you chat Miss Scylla? Thank you. Taking a look at the, oh, I need to mute someone. So taking a look at the graph down here, we have dollars. We notice that dollars are on the x-axis, and milliliters of ink are on the y-axis. So using the same method, we know that x comes first. So dollars, price $3. Let's find $3 on the bottom. On the x-axis, we'll go up to 2 milliliters, and that's how we plotted that point there. We could do the same thing for 6 and 4. Obviously, you're seeing that these points are already plotted. And so this line now extends. This line that we create it represents our proportion. So go ahead and I want you to answer. I'm going to redraw that line. I want you to answer part B on your own. How much ink will $17 be able to purchase? I'm going to fill out the graph, and you should have the graph filled out on your redo as well. All right, I'm going to go ahead. I'm going to move along because I want you guys to move into your IP. Silas, you have a hand up. You have a question?
Yeah, I have a question.
Yeah. What is it? Silas, can't hear you. Okay. So we're having some trouble hearing Silas. Let's go ahead. Anyone have a good estimate for how much ink we can buy with $17?
You didn't answer my question.
I didn't hear your question. You're having technical difficulties. Go ahead and ask it now.
So my question was that my redo number 2 is different.
Your we do number 2 is different. Okay. So you know what? You know what we're gonna do? Quincy also told me that something in his packet looks a little bit differently. Give me a thumbs up if your we do does look like mine on the page. Give me a thumbs up if your we do is okay. I'm gonna give you the answer to this because I want you to go to your IP time. Okay. So by using this, we can go find $17 along the bottom, and if we trace up from $17, we see that it's just about 11. It would actually be a little bit over $11. So just over $11. Go ahead and move on to your IP practice. I want you to do IP problems. Start with number 1. Do 1 through 4. One, 2. Actually, do 1, 2, and 8 right now. I'm writing them on the PowerPoint. Do numbers 1, 2, and 8. Silas? Go ahead,
My
Silas.
question.
Yeah. Go ahead. Yes, I'm listening.
I have a question.
I heard you. Tell me your question.
I don't have one.
You don't have IP?
No, I don't have
You
a
do not
question.
have a question. Okay, your hand was raised. My apologies. If you finish those 3 problems, do more. Do more problems. But I wanted you to start with 1, 2, and 8. If you've already finished 1, 2, and 8, then do the rest. Okay, scholars, we have about a minute left. So let's come back and let's quickly chat about what we learned today. This is a bit of a review. We did have a unit on this already. So what I want to see is everyone's eyes up on the screen, pencils are down. Lysandra, eyes up on the video. Naya, I don't see you in the video. Quincy, come back to the video. Okay. So what are the three methods that we can use to solve ratio word problems? We did three methods today. One person give me one of them. Go ahead, Joseph.
One of the methods we could use is that we could like make a graph and like point our mark in the graph.
So plotting, yep, making a graph and plotting the proportional relationship. Okay, Ms. Hill, can you call on another scholar who has a hand up? Okay, let's go with.
Sorry, unmuted. Yeah,
It's okay.
Lemuel. Yeah, Lemuel.
Lemuel, what's another one of the methods that we use today to solve problems with proportional relationships?
The ratio chart.
Ratio table. Ratio tables. And what was the third one? The third method which we thought about? We're just actually going over our time here, and I do want to respect your time. Our third method was using proportional reasoning. And a reminder of what that means, proportional reasoning is, you know, when we do, oh, what do we have to do to go from this number to this number? Multiply by 3. So we have to do the same thing to go from the other number to what we want. That's called proportional reasoning. All right, everyone, your homework is homework. And enjoy your break time. So Bintu, you have the packet. We spoke about this yesterday.
Okay, so I don't have the packet still because I could not find the one.
Stop the recording. Sorry, I'll stop. I got it. I stopped it. You want to stop the recording?